The Bull and the Red Giant. An introduction to Taurus. This constellation has fascinated humanity for millennia, serving as a celestial marker and a source of mythological inspiration. Taurus, the Bull, is a prominent constellation in the northern hemisphere's winter sky. Its visibility during the cold months makes it a favorite among stargazers and astronomers alike. It is one of the oldest recognized constellations, dating back to ancient Mesopotamia. These early astronomers identified Taurus and incorporated it into their mythologies and agricultural calendars. Taurus is known for its distinctive V-shaped asterism, the Pleiades, which represents the bull's head. This cluster is one of the closest open clusters to Earth, making it an important object of study. However, the constellation's most famous star is Aldebaran, a red giant star marking the bull's eye. Aldebaran's brightness and color have made it a focal point in the night sky. Aldebaran is much cooler than our Sun, with a surface temperature of around 3,900 Kelvin, giving it an orange hue. This temperature difference is a key characteristic of red giant stars. This cooler temperature contrasts sharply with its immense size. Aldebaran is estimated to be 44 times larger than our Sun. Its vast size is a result of the star's expansion as it ages. If Aldebaran were placed in the center of our solar system, it would extend beyond the orbit of Mercury. This hypothetical scenario helps us grasp the sheer scale of this giant star. The star's reddish glow and sheer size make it a captivating sight for stargazers. Its prominence in the night sky has inspired countless stories and observations throughout history. Aldebaran is relatively close to Earth, at a distance of about 65 light-years. This proximity allows astronomers to study it in greater detail than many other stars. This proximity, combined with its intrinsic brightness, makes it the 14th brightest star in the night sky. Its brightness is a result of both its size and its relatively close distance to Earth. As a red giant, Aldebaran has already exhausted the hydrogen fuel in its core and has begun to expand and cool. This phase of stellar evolution is a critical period in the life cycle of a star. Observations of Aldebaran and other red giants provide valuable insights into the late stages of stellar evolution. By studying these stars, astronomers can better understand the future of our own Sun and the fate of other stars in the universe. A celestial jewel. Unveiling the Pleiades star cluster. This cluster is not just a collection of stars, but a window into the cosmos, offering a glimpse into the universe's grand design. Nestled within the constellation Taurus lies a breathtaking celestial jewel, the Pleiades star cluster, also known as the Seven Sisters. This cluster has fascinated astronomers and stargazers alike for centuries. This open star cluster is one of the nearest to Earth, situated approximately 444 light-years away. Its relative closeness makes it an excellent subject for both amateur and professional astronomers. Its proximity allows us to observe its stunning beauty with remarkable clarity, even with the naked eye. On a clear night, the Pleiades can be seen without any telescopic aid, making it accessible to everyone. The Pleiades appear as a small, dipper-shaped grouping of blue-white stars, easily visible in the night sky. These stars are young and hot, emitting a brilliant blue-white light that stands out against the dark backdrop of space. The Pleiades have captivated skywatchers for millennia, inspiring myths and legends across various cultures. From the Greeks to the Native Americans, many have woven stories around these stars. In Greek mythology, the Seven Sisters were the daughters of Atlas and Pleione, pursued relentlessly across the heavens by the hunter Orion. This mythological chase is depicted in the night sky, with Orion forever following the Pleiades. The cluster's striking appearance and its association with these captivating tales have cemented its place in human history and imagination. These stories have been passed down through generations, keeping the Pleiades alive in our cultural consciousness. Beyond their beauty, the Pleiades hold significant scientific value. They are a key to understanding the processes that govern star formation and evolution. Their proximity and relative youth provide astronomers with an ideal laboratory for studying the formation and evolution of stars. By observing the Pleiades, scientists can gain insights into the life cycles of stars, from their birth in stellar nurseries to their eventual demise. Ancient light. Exploring the age and evolution of the Pleiades. Estimated to be around 100 million years old, the Pleiades star cluster is relatively young in cosmic terms. This age is a mere blink of an eye when compared to the age of our universe, which is approximately 13.8 billion years old. This youthful age is evident in the cluster's vibrant blue-white stars, which are still burning brightly with the energy of their formation. These stars are primarily composed of hot, massive, and luminous stars that shine with a distinctive blue hue. By studying the light emitted by these stars, astronomers can determine their temperature, luminosity, and chemical composition. This analysis is done through a process called spectroscopy, which breaks down the light into its component colors, revealing the secrets of the stars. These stellar properties provide valuable clues about the conditions under which the Pleiades formed, and the processes that have shaped their evolution over time. The presence of certain elements such as hydrogen and helium can tell us about the initial mass and the life cycle of these stars. The stars in the Pleiades are all gravitationally bound to each other, moving through space as a single unit. This gravitational bond is a result of the mutual attraction between the stars, which keeps them together as they journey through the galaxy. However, this gravitational bond is not strong enough to hold the cluster together indefinitely. Over time, the gravitational pull from other stars and the tidal forces within the Milky Way will gradually weaken the cluster's cohesion. Over millions of years, the Pleiades will gradually disperse due to gravitational interactions with other stars and interstellar gas clouds in our Milky Way galaxy. This process, known as tidal stripping, will eventually lead to the stars of the Pleiades drifting apart and becoming part of the general stellar population of the galaxy. From dust to stars, the formation of the Pleiades cluster. The Pleiades, like all star clusters, formed from a gigantic cloud of interstellar gas and dust known as a molecular cloud. These clouds are vast and cold, providing the ideal conditions for star formation. Within molecular clouds, gravity slowly draws together clumps of gas and dust, increasing their density and temperature. As these clumps collapse under their own gravity, they heat up, eventually reaching temperatures and pressures high enough to ignite nuclear fusion in their cores. This process, known as star formation, can take millions of years. In the case of the Pleiades, the intense radiation from the newly formed stars illuminated the surrounding gas and dust, creating a reflection nebula. This nebula, although faint, is still visible today, adding to the cluster's ethereal beauty. Section 5, Seven Sisters and More, the current state of the Pleiades. While the Pleiades are often referred to as the Seven Sisters, the cluster actually contains hundreds of stars. However, only a handful of these stars are visible to the naked eye. The 7 brightest stars in the Pleiades are all hot blue-white stars that are much larger and more massive than our Sun. These stars are classified as B-type stars, and have surface temperatures ranging from 10,000 to 30,000 Kelvin. Their high temperatures and luminosities mean that they have relatively short lifespans compared to our Sun. In addition to these massive stars, the Pleiades also contain numerous fainter, lower-mass stars. These stars, known as red dwarfs, are much cooler and less massive than our Sun and have lifespans of billions of years. Section 6, A Fateful Dance, predicting the future of the Pleiades cluster. The Pleiades star cluster, while currently a breathtaking sight in our night sky, is not a permanent fixture. Like all open star clusters, the Pleiades are destined to disperse over time due to gravitational interactions with other celestial objects in our galaxy. As the cluster orbits the Milky Way, it encounters giant molecular clouds, star clusters, and even dark matter. These encounters create gravitational tugs on the Pleiades stars, gradually pulling them apart. The process of dispersal is gradual, occurring over millions of years. Eventually, the once compact cluster will spread out, its stars scattering across the Milky Way. However, even as the Pleiades disperse, their individual stars will continue to evolve and eventually meet their own unique fates. Section 7. Windows to the Universe. The importance of studying star clusters. Star clusters like the Pleiades offer invaluable insights into the lives and deaths of stars. Astronomers can study these clusters to learn about stellar evolution, the chemical enrichment of galaxies, and the dynamics of star formation. By observing clusters of different ages, they can piece together a timeline of stellar evolution, from the birth of stars in molecular clouds to their eventual demise. The Pleiades, with their relatively young age and proximity to Earth, provide a unique opportunity to study stars in the early stages of their evolution. These observations help astronomers refine their models of star formation and understand the conditions that give rise to different types of stars. Furthermore, studying star clusters can shed light on the history and evolution of our own galaxy. Section 8. The Ever-Changing Cosmos. A final reflection on Taurus and the Pleiades. The constellation Taurus, with its prominent red giant star Aldebaran, and the nearby Pleiades star cluster stand as testaments to the dynamic nature of the universe. From the birth of stars in molecular clouds to their eventual dispersal and demise, the cosmos is in a constant state of flux. The Pleiades, once a compact collection of stars, will eventually disperse, their individual members scattering across the Milky Way. Aldebaran, having exhausted the hydrogen fuel in its core, is destined to shed its outer layers, forming a planetary nebula and leaving behind a white dwarf star. These celestial objects remind us that the universe is not static but rather a place of constant change and evolution, where stars are born, live out their lives, and eventually fade away, only to be replaced by new generations of stars.